Hello, everybody, and thank you so much for being here today. My name is Jonah from Spotlight, and today we are talking to Andreas. How you doing?
Fine, thanks. How are you doing, Jonah?
I'm quite well. Super excited to be here. I know we were talking a little before. You were showing me what some of what you're going to show us, and this stuff absolutely fascinates me. There's so much behind all of these things we take for granted or just use in the world. And it's going to be a blast, but I just want to make sure everyone's in the right place, that you can hear and see us all right. So if you're here, hop in the comments, let us know that you can hear and see us, where you're tuning in from, something you're excited to learn today, maybe how you heard about Andreas or Spotlight. We love hearing all of those things. And if you're watching the replay, hop in the comments, do the same. Believe it or not, we do come back and read all of those and love hearing where you're at, where you're coming from. And if at any time throughout the presentation, I know there's going to be a lot shared here, you have to get away from the computer, your dog comes in the room, anything like that, don't fret. There will be a replay available. It'll be here on YouTube. It'll also be on the Spotlight event page and emailed to you along with the course offer, which we'll talk about later. And last but not least, just to make sure everyone is in the right place, today we are going to be talking about how to learn data engineering the right way. And we're going to show you step by step the best way to learn data engineering so you can get a six-figure job. And I just want to call out a couple people tuning in from India, from Nigeria. We got some folks from Ireland. Love it. And it looks like everyone is here, Andreas. So I don't want to take up any
Nice.
more time because I know you got a lot to share. So let's dive in. And if you can introduce yourself, and then we'll get rolling.
Yeah, thanks. Um, you made a good point, Jonah, by the way. It's the invisible thing. It's the plumbing of data science. Nobody knows it, but it's just there and it works.
Yeah,
If it doesn't work, people have big problems.
that's when we hear about it. Yeah, right.
All right.
All right.
Yeah, welcome everybody. I see a lot of people. That's nice. Hi, thanks for the comments.
Oh, Andreas, sorry to
Yes.
interrupt you. One thing I forgot to say, if you have any questions throughout this event, pop them in the comments. We are going to try and answer them as they roll in. If we don't right away, we're not ignoring you. We have set aside a Q&A at the end to get to all of those. Just wanted to make sure people knew they can ask all of those questions throughout the presentation.
Exactly.
Now I'll actually get out of the way.
I was just going to say that, Jonah.
Oh, sorry. I need to trust we're working together here. All right, I'll get out of the way. Let's dive in.
So, a quick about me. Some of you might know me, some don't. I have a YouTube channel, and I'm basically full-time with working in data engineering. I started with this back in 2012 at Bosch Rexroth here in Germany. I'm coming from Germany here, living with my wife and the two kids. And I started basically working on predictive maintenance products. And through that, I got into touch with the whole data engineering thing. Back then, it was called big data architecture. Like it wasn't really clear. It was all quite new, especially here in Germany. And so I started and figured out, okay, I have a problem, a lot of machines sending data in. I can't work with the typical databases like a relational database, and I need to have something else. I need to find a better solution. So this was when Hadoop came into play, and back in the day, the whole big data thing with all the tools. And so I started my journey there as an architect, then later as data engineer. I took over the data engineering team in the project that I was working on once we grew, and later then I took over a data lab where I was working with engineers and I was working with data engineers. Since last year, I'm full-time teaching. I'm working at my own company, Learn Data Engineering, where I do my academy, or I have my academy with online courses and with coaching. You can find me, as I said, on YouTube. My name is my channel, Andreas Kretz, and on Twitter at AndreasK. So some of you might think, okay, data engineering, what's that? And the example I want to show you is self-driving cars. right? A lot of people still talk about self-driving cars. On the left, you have the Tesla, and on the right, you have the data scientist who wants to figure out a solution for the self-driving car. Now the problem is, okay, these two are connected, but there's something missing in the middle, right? The car is generating the data, and the data scientist wants to work with the data, but so how do you bring this together? And how you bring this together is with a data platform, and this is where the engineer comes in. So the engineer is basically in charge of creating the pipelines, or creating the platform and creating the pipelines to let that data flow. For instance, on the left here, where we have interfaces for the car, how the car can send data to the platform. Within the platform, the main two things, processing and storages. So the data can be stored, the data can be processed. This is also where the scientist comes in. The scientist uses the storage, uses the processing. Usually on the right side, then you have your visualization where, either user interface or a analyst working on this on the platform. So this is the setup. This is where the engineering is. That's what I meant in the beginning, where I said to Jonah, it's invisible. Usually you don't see this. This is hidden, but it's a big mess if there is something happening, something going wrong. Just like the plumbing of data science. I'm always saying it's called. So I have two examples here that I want to start with, and this is also how, when you start learning data engineering, what you need to understand. There are basically two parts of a data platform. The first part, there's one part, is the analytics platform, and the other part is the transactional platform. It's usually within the platform. Sometimes you have projects that are only working on the analytics side or on the analytics platform side. Sometimes you have projects that are mostly on the transactional side. So this is two very important things that you have to understand. Now, what's an analytics platform? What's going to happen? So with Tesla, we know that once the car is in the garage or at home at night, it's going to start uploading data to the data platform at Tesla. It used to be a few gigabytes at night, where this thing is just uploading data through your Wi-Fi. So what's going to happen is the car is going to drop data into a data lake, for instance, as files, as measurements. Within the platform, you have a batch process, an analytics, that is going to take that data, start at night at 1, 2, or 3 o'clock, take the data from all the cars, going to feed it through, process it, and going to create analytics results, for instance, and puts this, for instance, into a data warehouse. So that once on the next day, the fleet management or the analysts are coming in and want to manage the fleet, want to check out how many miles have been driven, what's the status of our cars. They can just log into a user interface or their tools, get access to the warehouse, look at the results, what has happened, or what has basically been calculated over the night. This is one case. The other case would be the scientist that actually sits here, that creates the processes, that tries the machine learning, tries to teach the algorithms to build models that enable functions. For instance, the self-driving. Of course, the self-driving is a very complicated topic. It's not like a single model that works there, but I think you get the idea. So this is usually an analytics platform. Very often you find data lakes, you find data warehouses, you find batch processes that bring the data in and then create some analytics results based on the whole data of all the cars in this case, and then basically enables the user to access this data. This is the case for an analytics platform. As said, very often data lake, data warehouse, some batch processes. The other case is transactional processing, transactional platforms. This is very often very near to the use case itself, or a use for the customer. the analytics platform in our case was a lot about how did I call it? I already forgot. Fleet monitoring. So it's within the company that the company understands better what is done with the product. Transactional very often is the main use case, or something that the customer gets. In this case, it's okay, you have a flat tire here on the left, and your car is going to automatically then send data to the platform, so something can happen. In this case, in this example, I have basically an API, a programming interface that allows the car to send data to the platform. In there, most likely it will flow into a message queue and then be immediately processed and put into a database. And for instance, in this database, then it generates an alarm. The service technician sees this on their mobile phone, look quickly into the telemetry and call you. We see you have a flat. You're here in this location. We're going to. Do you need assistance, or is everything all right? Stream processing here in this case needs to act very fast. Data is going to flow through this, and it's also focused on in this case, a single car. Right? When you look back or think back in the analytics part, it was more concerned about the fleet, about the whole thing. This is more concerned about individual messages, individual transactions. In this case, the transaction is basically the car saying I have a flat tire. Could also be a sale in an e-commerce store. So this is what you very often see. You very often see message queues. You very often see APIs, some stream processing in this, because it's going to act quick and not just like once a day or once an hour. And you, instead of having data warehouses, you're going to see relational databases or NoSQL databases in this case, very often. How does such a data platform usually look? And when you're going to learn this, there's so much out there. You can go down a rabbit hole and never come back and never learn something. I created this blueprint and I used it for years now, and it always works. Whenever I look into platforms, think of this as that you have these 5 areas that are important. You have the connect area or the connect phase, you have a buffer, you have a processing phase or process, you have storage, and you have visualization. It's always the same. In connect, this is where you get the data in. So data is going to come from the left, for instance, with APIs or data integration tools, where you draw the data out here, basically from external tools, or external APIs or data warehouses. These data integration tools are going to basically run ETL jobs, bring the data in, or you stream the data in through APIs. Then you have buffers, where you have, for instance, the message queues or caches, your processing framework with stream and batch processing, also with scheduling, and then the storage is here, like relational databases, NoSQL databases, data lakes, data warehouses. And then on the completely, I need to push this way, completely on the right is then visualization, for instance, with web user interfaces, BI tools, or mobile apps. So this is how this usually fits together. Look into, or I have a few examples here how this works, and we're going to look at the Tesla example with just these 2 for the analytics in a second. The thing is, you might wonder, okay, where are the tools here? Where are the tools? The important part to understand is the tools are always the same. So you need to create APIs. There are different tools that solve this issue. Data integration tools, you could just Google data integration, top data integration tools. You're going to find the data integration tools. Caches, there are only a few parts of message queues. They always work the same. It's literally always the same thing with a bit of a different name and a bit of different functionality, but you can most of the time see this as the same. So if you know, I have a a database. For instance, I have MongoDB. What's the document database on AWS? Then you Google, you're going to find DynamoDB. On Azure, you're going to find Cosmos DB. So it's use this as a way of categorizing which tools go where, and learn only a bunch of them. Don't learn everything, anything. No, don't learn everything. Just a few selected things. So let's quickly go back into the analytics platform that we just talked about. So with the analytics platform, how did that work? The data came from the car, basically from the left. There will be an API involved in this because you don't want to have your platform open to the public. So most likely this will go through an API and then into the data lake as files, right? Then what we had was we had some processing. So this is where we have some batch processing. Batch processing is going to run the job, is going to access the data in the data lake, the files for the day. Most likely they're partitioned by day. Analyze it, put the data back into the warehouse, and then bring the BI tools in, let the BI tools connect to the data warehouse, and then visualize the data. Something very, very straightforward. You see the data basically moves here. Data basically moves from left to right here, right? Comes in from the left to right, and the processing is more here than the vertical way, where you have the buffers, the process, and the storage. As I said, horizontal is more the flow of the data from getting data into the visualization part. So this is for the fleet management, or for the data scientist who is going to analyze the data. Data is going to lie in the data lake, run a batch job, run a few tries, try a few algorithms, modify the variables, the hyperparameters, and so on, and then write the result somewhere, maybe in a NoSQL database, could also be, or in a data warehouse. So that's the idea. Transactional is a bit different. So with the transactional, basically we had the car, we have the flat. The flat is going to trigger something in the car. Car is going to write data into the API on the left, and then the API is going to write the data into the message queue, and from there, the message queue is going to the data in the message queue is going to be processed by the processing framework with the stream process, and immediately been written into a NoSQL database or relational database, where you have then your app access that data. Right. So this uses the let's say the left part here, the streaming part with message queue streams, stream processing, and NoSQL databases. Very often you're going to encounter this. So why, you might ask, okay, why bring in message queues here? The good thing with message queues is that they basically break your they are actually buffering the data. That's why I call this buffer, by the way. This means if you have a lot of happening and the cars are sending a lot of data, like it's in the afternoon, everybody's leaving the office, driving home, a lot of stuff happening. Let's say the car is sending more data than the actual stream processing can handle at once. Then you have the thing where you have your buffers, your message queue. This means the stream processing can actually catch up, or this can level out a bit the peaks. So you're never running into the issue that you overpower your stream processing or the writing into the database, because the stream processing is only going to fetch as much from the data from the message queue as it can. So this, you see the difference here. Let me go back here, the analytics part, this basically moved horizontally directly into the data lake in this case. And then you had the vertical processing with the transactional. This basically moved directly through the processing, through the vertical here. So the processing is in this case actually earlier, the analytics part. But again, Analytics part here is only limited to individual transactions, individual things that happen. Yeah. Now, when you get into this, you might ask, okay, what's the step-by-step process here? How can you start with this? In my academy, I have basically 4 modules, and these are also the 4 steps that you should take. The first step that you need to have is engineering fundamentals. This is the important part. There are more than this, but the main things is you need to code and you need to understand how to interact with relational databases, use SQL queries. You can learn this within the academy, but it's also good if you already have this. So if you're coming from a traditional role like a database admin or a software developer, you most likely can get into this very quickly because you already have Python skills and you already know how to work with relational databases. It's also not very hard. So this is the fundamentals that you actually need to start. The second module I also have in the academy then is helping you better understand, or you need to understand better how do these platforms work and how can you build pipelines, because there are a few pipeline designs that are, you see them all the time. It's not witchcraft or rocket science. These patterns you see all the time. So platform pipeline fundamentals, that you understand how this works, how you can build these platforms or pipelines. Sometimes you need to do this especially if you're in a startup. Then platform security, I have a part that you also need to understand. How can you secure your platform? Don't make the mistakes and have some loopholes where people can do bad stuff. And then back in the first module where I said SQL and Python, this is also where databases come back in. Databases very often are the center of your platform, because they basically host the data, or data stores. They host the raw data, they host the analyzed data, they make the data accessible for the visualizations. So it's very important to understand, okay, what are relational databases? Which different types of NoSQL databases are there? And there are only a few types. As I said, they're very often named differently, but if you understand the types, just like within the blueprint, if you understand what is all under storage, then it's always the same. Data warehouses and data lakes. Once you understand what they're used for, then you need to understand, okay, how can I actually design a schema for this? So how can I, if I have some data, how can I actually create this, or design my schema to store that data and make it accessible in a way that is very, very performance oriented? Not like I use a database that is wrong for the use case and it takes forever to get the data out. So there are a few things that you have to understand. Once you know this, basically, so you can code, you can interact with databases, you understand how to build a platform and pipelines, and you understand which stores to use and to design. It's already very rounded off. And then you should start and should get into individual tools. Now here's an example of what you can do. And this is also how I started within my academy. Docker Fundamentals, by the way, is coming next Monday. So Docker is a bit outside of this platform, because it's a part of the platform. I would say Docker is very important. If you haven't worked with Docker, Docker is basically a way how you can deploy tools, how you can deploy your processes or deploy your code on the cloud platform in production. It's very, very good. I all the time, whenever I create new courses, I immediately think of Docker and using Docker to host tools to develop my code, to publish my code. You need to understand how to work with APIs, basically from the connect part here. Understand your APIs. message queues, so you know how to, so you have something from the buffer part. Then processing frameworks, that you have one processing framework that you understand. A NoSQL database, for instance, a document store, a data warehouse, and a data lake, that you understand these things here. Visualization, very often it's not that important for an engineer. It's important for, let's say, internal platform monitoring, platform process visualizations. It's very often it's not that super important for you. So that's what you need to focus on. There are still no tools in this, right? So I hope you get the idea with thinking first about thinking this in parts of a platform, or in templates. There's the API template. Okay, how can you create the APIs? Which are the right tools for this? Message queues, which are the right message queues? Which are the frameworks, and which basically fit together? I have an example here that I can show you. So this is from one of my courses. I have a course that is basically an end-to-end project with where we on the one side, here on the left, we stream in from an e-commerce store. We stream in invoices and items on these invoices, and then we create in the connect phase an API ingest with fast API. This then sends the data into Apache Kafka. From there, we process it with the streaming notebook from Apache Spark on a Jupyter notebook. It's going to write into MongoDB as a document store, and as a visualization, I just created a Streamlit visualization where you have basically two input fields for the customer and the invoice, and it's going to show you then the data in tables. So this is how you can insert the tools then. An API tool, let's use Fast API, or let's use, how's the other called? I just missed it. I don't remember. Google it. Usually how's it called? I don't remember. Kafka, Spark, these two very often fit very well together, MongoDB and Streamlit. So this is how you can do this. Now, as I said, depending on the platform, it makes sense or doesn't make sense to use this combination. So if you're on, let's say, if you're on AWS, you most likely are going to use a different combination here. You're most likely going to use API Gateway, which is basically like Fast API, just from as a hosted service. Instead of Kafka, you most likely are going to use Kinesis on AWS. It's literally the same thing, just hosted. Process, either you host something like Spark here, you could do that, or you just use a Lambda function and basically stream your data through with Lambda functions that dock onto Kinesis. Storage, you could go into DynamoDB and then visualize it. You could just leave Streamlit here, or use another tool. So this is where you then do the research. Okay, I'm on that platform. What fits to the connect phase, to the buffer, to the process store? And for that, what I've done is I basically created 6 example projects, and these are end-to-end projects. How you can basically experience the analytics platform part and the transactional platform part. 2 on AWS, a data engineering on AWS example project where you learn from the basics. How can you set up a platform on AWS? How do you install or set up the tools? How can you run the data through this? How do you do the schema design and everything? Then a part with machine learning and containerization on AWS, where we actually host the machine learning algorithm and where we use Docker and we use ECS, Elastic Container Service, and the container registry to actually host our visualization there. We have something on Azure, an Azure project, the document streaming that I've just shown you as an example, something with time series databases, because that's also something that is very close to my heart, time series databases. as of course, as you understand, I'm coming from the IoT field where you have a lot of time series data measurements from machines. So this is something that has always been very close to me. I haven't, I for the teaching, I got into InfluxDB, and I like it. There are also some different databases that are some other databases that are very good. We also have a course on Hadoop where you see how the analytics platform part on Hadoop works. So these are the things that you can learn. As I said, for the first 3 modules, the basics, the platform pipeline design, and for the fundamental tools, we actually have 13 courses in the academy where you can learn all this. Generally, as I said, the academy is a huge, basically step-by-step course. I'm always thinking of or how I built this is individual. I don't like individual courses. You find a lot of individual courses out there. The problem is it's never a holistic view on the whole thing. So you can never understand the whole thing and understand how everything fits together. So that's why I did this. This basically is one course. You have unlimited access during your subscription. I have a subscription model here where it's either for 12 months or 24 months. And you get all the courses that are currently existing and the new ones during your subscription that are coming out. You have access to all the example projects, the 2 AWS projects, the Azure, and so on and so on. We have a private Slack group for all the students, with currently over 500 students on there, where you, even if you don't, if your subscription ends, you still have access to that, and you can get course certificates for this. Yeah, so this is my approach to this, keeping it hands-on, learning basically from the basics. And Jonah, you can bring me back for now to the main screen with you, or like this.
Yeah, hello. Yeah.
So this is basically how I built this, to have more a holistical view, and not just learn this or that, and then you're stuck with this, and,
Right.
and create projects to actually understand how it fits together and that you can show. So the best case I always tell my students is go do this. Go through the modules. At the end, do 1 or 2 from these projects that you find interesting. Document them, for instance, on your GitHub. How you solved this, why you solved it this way. Document your code, improve on the code that I have in there, and then put it into your CV and show it off as something that you can actually do. That's
right.
That's the goal here.
Right. I love that. And so, real quick. Oh, excuse me. Now's usually when I say hop in the chat and start asking questions for the Q&A, but we have a very active crew and we already have a ton of questions. So feel free to drop more if you have them. And before we dive into the Q&A, I did just want to talk, because we were talking a little bit before we started the presentation offline, that you've organized this a little different, and it's not necessarily one course. When you buy this, you get a year's access to a wealth of courses, right? A kind of hub of all of these different courses.
Exactly. That's for me, the goal is to always bring in new content. We bring in once or twice new courses, either full projects or smaller courses, so that you always get something new and you always stay on top of what's happening on the market.
Right.
What's going on.
Right.
Because we're in a very, very quick moving environment, and you need to stay on top of it.
Right. And honestly, that works as a great segue to start at diving into questions. Part of the sky is disappearing.
It's the sun is right now. It's coming in here exactly that it shines on my green screen and it's like bombarding me with green.
I love it. But yeah, if you're up for it, I want to try and get to as many questions as we can, and we have a ton of great questions. So coming first from Deepak was, based on your experience, I wanted to confirm if the data engineering title profile is something that will last more than the classic data analyst or data scientist role. So, for someone just interested in getting into the space, but they're trying to figure out what the best profile is for
Mm.
them, what do you think the advantages are of data engineering?
So, ch- coming back here, one point, the first point I want to make on this comment is what will last more than the analyst or scientist role. These roles will still be here for a long time. Analyst, scientist, engineer. The idea with these roles is that they're supporting each other, right? So the engineering part is going to fix the platforms, work the pipelines and everything. The scientist is going to run the analytics part, and the analyst is going to then prepare stuff for the business intelligence or for the management or whatever, right? So doing the big insights. What you need to that's what you also asked, Jonah, is what should you choose? The choice is always the engineering part is more of the computer science part. So if you're not very interested in how stuff works in the background, how to work with tools, how to like work with the data to bring it into the right format and to make sure that the schema fits and everything, then engineering might not be the right thing for you. Then
Right.
most likely you want to move if you're more into, okay, I want to figure out the best analytics solution and I want to create some nice results analyzing this data and figuring out the sentiment for whatever tweets or something. Of course, this is a very simple problem, but
Right.
I think for the idea is that you want to find a good solution and then visualize these results. That's more of the analyst scientist role. So try to figure out, do you want to analyze the data or do you want to work with the data and work with the platform more in the computer science part? That's the important decision to make here in the beginning.
Right. Well, but I did love to the specific question, like, will one role outlast the other?
Yeah.
It's like water or flour aren't going to outlast each other. You need both to make a cake,
Yeah.
right? So they're
Yeah,
all
exactly.
always love it.
It's also not that strict very often. If you're in a startup, maybe they don't have an engineer and you're a scientist, you need to know that, or you need to get this engineering knowledge to start with the platform. That's why also in the academy I have a lot of data scientists, because they need the engineering knowledge in their startup to quickly do something.
So you're gonna gain whichever profile you choose. You're gonna gain by knowing the engineering aspect of it.
Yeah.
Yeah.
Especially for the data scientists. The analysts most of the time want to move to the engineering part, but the scientists very often they need to want to add this to their knowledge.
Right. And Deepak had a follow up just to that, which is it really possible for someone to start from scratch with no prior data engineering experience to become a data engineer?
Yeah, sure. It's
Yeah,
literally
yeah.
the thing is, it's always when you, let's say you start actually absolutely from zero, you most likely struggle the most with the coding part, and you struggle the most with the databases in the beginning. So this is something where you have to invest some time, and you need to fight through this. Then
Right.
it shouldn't be a problem, because it's very, stuff is very simple.
Right.
You don't need, very often you see all these big roadmaps and everything. You need to learn is you need to go step by step. And for junior roles especially, you don't need to be the super expert in Apache Spark. You need to understand how it works. You need to have worked with it, and then, for instance, that's not a problem.
Right.
So
right,
yeah,
right.
it's possible. It's, of course, it's work. You
Right.
need to practice coding. That's why I also do these projects, so you understand how to, so you can practice and you can improve. But yeah.
Yeah. And a great follow-up question for today's world is it possible to land remote data engineering jobs from anywhere in the world? Can companies trust someone from halfway around the world with their databases?
Absolutely. absolutely.
Yeah.
That's something that since COVID happened, it's companies are moving to this crazy. Yeah.
Right.
It's so remote working is out there, and it's going to last. It works for companies, so that's yeah.
Yeah. Uh, And then there are a lot of questions in here, Andreas, that I'll be honest, I don't have the knowledge to know what people are talking about. so, so I'm going to ask, and you may have covered some of these, so feel free to
Sure.
say so.
Yeah.
But I'm just going to throw them out so we could serve. I know data warehouse is different from OLTP, but which one is better as a career? Because without OLTP, data warehouses won't get data.
It I would which one is better as a career? So a lot of companies use the OLAP part, use the analytics part of the platform in the very often, especially the bigger companies. So you most likely are going to find this a bit more often. It's a bit case by case. What I would do is I would go and I would, with that knowledge, I would look into job descriptions. I would search data engineer, whatever for companies you want to go to, you want to get a job at, or a specific locations or whatever. And then I would look into, okay, what are they requiring? Are they more in the OLTP part with NoSQL database and so on and stream processing, or is this in this area like in banking? Are they most of the time doing OLAP and having data warehouses? Then most likely, if you want to get a job in banking, then you would move towards the data warehouses part.
Oh,
So
interesting. And it focus more on the industry you'd be interested in getting into, do a little research what that industry
yeah,
needs, and that'll guide it. And then
yeah, that's very important.
Christopher was hopping in here quick. What is OLTP? Can you define it?
I'm sorry.
Thanks for asking that,
So
Christopher. 'Cause
yeah,
I don't
very
know
good.
either.
So it's online transaction processing, and
Got you.
OLAP is online analytics or analytical. I think it's analytical processing. So it already implies the T is for transactions, the A is for analytics for the whole thing, and this is also where you have where the distinction comes. Data warehouses are OLAP. Usually the databases that you know from everywhere, the relational database, the NoSQL, they are usually OLTP because they are concerned with individual transactions, making sure that this credit card transaction is in there and is not dropped somewhere.
Right.
And
Okay.
so, yeah.
Interesting. So this is a question I'm going to use a little bit as a plug for your course, but tag on as well. Recently, I've started as a data engineer intern, but I don't know anything about this and how to excel in this role. The resources, as prior to this, I know SQL and Python. So how does a rookie become a pro? I imagine your course is a great place to do that.
Yeah.
but but
Hmm.
are there some other just resources and things, or even if this person does get your course and is diving in, are there good free resources to practice outside of it and stuff like that?
So, first of all, for Arnav, what I would ask is, why don't you ask? You're an intern. You need to ask a lot more questions. It sounds like you're not asking enough questions to the people who are taking care of you during this internship. So try to gain more information from them. Try to gain more knowledge, and this is going to help you through this.
Oh, so kind of as the internship, don't be afraid to ask questions. Use
Of
it as an
course.
opportunity to learn those
Yeah,
things.
it's
Yeah.
very important.
Yeah.
If you want to have some resources, for individual tools, there are a ton of courses out there on Udemy or something. If you just want to learn a single tool, go there. It's absolutely, you can get a $20 course, and also on Teachable, of course.
Right.
I don't, but I don't. I have to admit, I don't know. I haven't researched on Teachable who has a good course for this. Maybe Jonah, you have something afterwards. But the idea is single courses. Go look for single courses. If you want something that is more like end to end, just go into the academy. I have these projects all laid out. You could just go in there and use this as a template. If you don't want to spend the money and join the academy, just go for yourself. Give it a try. It's
Right.
not
So
that
you can
difficult to start.
you can browse the course before purchasing it.
Yeah, I have on my webpage. I have basically every project laid out. What are the
Okay.
ingredients of these projects, and so you can look at it. It's going to, of course, cost you a lot of more time than just going in and using it. But start with this, and for individual tools that you have heard, just search on the internet. You're going to find some good resources for these.
Love it. And I'll do the quick call out to Spotlight, which the website is in the description. If you go to the Spotlight website and click on courses, we do have segmented like computer science, data engineering, where you can see events we've done in the past and relative courses. So we've also done a bunch of events with data engineering and stuff like that. So if you just want some more free resources, events like this are available there. But
Very nice.
just to keep plowing through, we got so many questions. So one question, please. Do we need web scraping in data engineering? If so, how deep?
It's interesting. People ask me this quite often. I never really saw a use case where people do this in scale, because web scraping, often the site that you're scraping doesn't want to be scraped. So it's it can make sense, but usually I'm not the big web scraping guy. It's one of these use cases where you say, okay, I have an analytics platform. I want to bring in some data. I'm going to write a job that is going to scrape there from the site and bring the data into my data lake or something. But yeah.
Yeah.
I don't think it's super important. It's more important to work with databases, that you understand, okay, I have some databases. For instance, in companies, they have a lot of databases laying around where you most likely need to bring the data into your platform, and that's more important,
right,
than web scraping, because it's very specific.
Had a wonderful question from Sebastian about just working with you more directly. I was wondering if Andreas could tell us about his data engineering coaching that he offers on his site. What would be a good fit to work together? Do you provide guidance on what jobs we should apply to? So you offer like one-on-one coaching, or how does that coaching work? And when should someone take advantage of that in their kind of path?
So I'm actually right now in the process of remodeling the coaching.
Okay.
So I'm not 100% sure where it's going to go. How I've done this in the past is basically either I had groups of students or one-on-one coaching, where we basically figure out, okay, what's the topic that you, or the industry and the companies you're looking for. What are the data sets or data sets you most likely fit to that? Now fit to that, and then we're trying to build a platform where we say, okay, in the job descriptions there are these tools you mentioned all the time. Let's build something with this. Let's build an end-to-end platform. Let's use this as the project to learn data engineering, and then document it and putting it into the CV. I'm not 100% sure how I'm going to bring this back right now. So a good fit to work together is right now just use the academy. I'm on Slack all the time. If you have questions, add me there. I'm bringing in this information right now. I'm working on bringing this information for how to do this, or how to create a nice CV, how to do job research and so on. I'm bringing this from the coaching, the prepared content, bringing this also into the academy for now.
Love it.
So
and then great question here. Each company or business has their own tools for data engineering. So which ones do we have to learn?
this comes down to what I've talked earlier about. You don't need to learn each tool. You need to have remember from the blueprint: connect, buffer, process, store, visualize. Have at least one of them on one platform for each of those. Because let's say you start with, with the project that I had with Kafka, Spark, MongoDB. If the company that you apply to, they are on AWS, and they see you know how these work, then they know, okay, that you can also do this on AWS, because it's most of the time it's the same thing. It's just named differently. So start with one. Of course, if you want to start with AWS, for instance, AWS is, I think, a few months ago, I saw a statistic: 60% of all data engineering job descriptions is AWS. Woo! So it's a safe bet to start with AWS and work with that, or start Kafka, Spark, something that's also very, very popular.
Right.
And
man, it's easy to forget that's why Amazon is worth so much, right?
They're good.
They're good. They got it. Yeah. It's not about buying your conditioner there. Yeah. And I just wanted to draw this a little more to a point, because a lot of the questions were about like, which skill set do I need? And I'm hearing kind of a common theme from you that I just want to like resynthesize, which is to do a little research in the industry you would be passionate about. And that's what informs the skill sets you're going to need, right? Yeah. Rather than just like because otherwise you're just left trying to learn everything to be like the most valuable player, but you're not going to be able to do that.
That doesn't work. Yeah.
Exactly.
You need to do a bit of research. Of course, if you feel like this tool is very cool and I want to get into it and it's more niche, do it. It's not like oh no, only focus on the interesting part. There's 100% somebody who is very interested in you having that skill.
Right.
But generally, it doesn't really matter that much, as long as you have a comprehensive as long as in every one of these parts you have knowledge, and not like you just know a processing framework and that's it. It's a bit weak, for applying to jobs.
Right. I have a good question that puts you a little on the spot, but I think is wonderful. There are courses from IBM and many others online. How is your course different from them, as they also offer recorded live programs? So when you built this course, what's different about what you set out to do with it?
Yeah. As I said, the holistic part is for me very important. That this is not just like one of many courses within IBM's library or somebody else's library where you just get the courses and that's it. For me, the part is very important to have these courses that fit together, that you understand these are the skills in this basically step 1, step 2, step 3, and then do these full end-to-end projects. Most of the time they don't have these full projects, and that's a problem. Or they just have one. Basically, the whole course is just one project, and then you know this one project, and that's it. So that's why I do a different part. Fundamental tools. I bring in more tools usually, and then I add a big course on top of this as well. Right. So that if you want to,
and so that's also like within the whole academy. If someone was really ambitious and wanted to tackle a bunch of different like projects, they come out of the academy having actually built these things.
Exactly.
Right.
Yeah.
Yeah.
Built this, used this, documented this. Yeah. I also had a student who said, I have a good idea for a project. I wanna teach this to people. So we did this. The Azure project is actually it's not for me. It's from Christian, who is a student who said, I know this. This was interesting. I actually did this. Can I teach this? Because this is additional to what I've learned. And then I said, sure.
Awesome. this is you kind of alluded to this, so we can answer it quickly, but what is the USP of the course in Data Engineering Academy? Will anyone with a little like Python and SQL knowledge be able to start from scratch? Kind of what is the minimum
Yeah.
requirement
That
for someone to
that's
dive in?
that's literally what I would say is a perfect start. I have two courses for Python, two beginner courses, one for Python, Introduction to Python, really if you have no idea about it, and then a Python for data engineers, where we also work with pandas and accessing relational databases and so on. So that's actually a perfect fit. If you want to make the change there and you come with this, you have a very easy start in all
Love
of
it.
this.
Love it. Uh, I'm just firing through questions here trying to get. But how long does it take to complete an average project?
Whew, that's a good question. I have projects that most likely, I think, 2 hours of video recording, for instance. Then most likely you need 2 hours to do it, and then some time for improving it and documenting it. Maybe like a big end to end project. So maybe 10 hours, I would say at least for I would say for a project.
Okay.
But you need to go through the first modules and not immediately jump into the projects, because then if you skip the platform and pipeline design, then you most likely have a hard time in the project, because yeah,
Yeah.
you're required to have the skills or the knowledge that I teach you there.
Right. And then I'm going to kind of lump these two questions together. Are there any plans of a course end-to-end project on the Google Cloud platform, and then also GCP and BigQuery courses? Do you have plans to include those things? Are they in there, or where are you at with that?
I would love to have one in there, but right now it's the time that is for me difficult. GCP is something that I don't have that much in there. I have a course in the fundamental tools, modern data warehouses and data lakes, where where on GCP I set up BigQuery and use how's the data, the cloud storage. Is it cloud storage? Basically, the file storage, we are using this on that. So we put a CSV file there, access it through BigQuery, and then use Data Studio to access basically the data that is in, or to visualize the data that is in BigQuery. So these three parts, that's what I have. But a big project, like an end-to-end project for GCP, it's going to come. I don't know when. I'm focusing. The next ones is going to be something with Snowflake, DBT, and Airflow. These three things I think are very hot, are very important right now. I'm focusing on these, and then afterwards, most likely the GCP thing.
Love it. And is there somewhere people can sign up for an email list or something like that, where they would be notified of a new course?
Yeah, on the side there, on the top right is a subscribe button where
Cool.
you can, and also on the bottom there are buttons there that tell you subscribe to the site,
Right.
to our email list.
Love it. And
Yeah.
we'll just we only have time for like two more little questions, so I'm just going to make them about your course, which is, do you give free credits for any of the cloud platforms while you're in the course, or how do people access those once they're in the academy?
That would be nice, but I don't have free credits. The problem is these platforms are not giving out, or I haven't been able to get in touch with somebody who actually could make this available. The good thing is, though, these platforms have free credits usually. So AWS has a free tier for a year. The downside is, I think Kinesis is not in there, so most likely you're going to pay $20 or something then for doing these projects.
Right.
GCP has I think 3 months, $200, and Azure also has like a free tier. So you're not starting by, or you're not going to pay from zero, but unfortunately, maybe I can get, maybe somebody can help me get in touch with, maybe you see
Well,
this and you know somebody from AWS and Azure, get in touch.
well, I'll say I've seen other courses like yours that charge a lot more and then
Mm,
advertise free credits. So for anyone going out there,
okay.
what they're doing is they're making you pay for it. They're just making you pay through them. So I
Okay.
appreciate you. Your course is much more affordable, much more robust, and so I just want to
Yeah.
call that out to see, because you can see a lot of stuff out there when you're looking for a competitive course that says, "Oh, free this, free that," but it's
Yeah.
nine
It's your,
times the price.
yeah.
So it's
That's also something I'm trying to keep the price low on this.
right,
That's why I have the coaching, and most likely I'm also going to do coaching for team coaching for companies in the future. So for the students, I can keep the price low. You can learn this very very easily, and the companies are going to basically, yeah,
right, right,
do
and
the
then
do the yeah, the large part.
right, and then the last question we have time for is there a trial period on the course or any aspect in that way? Or my understanding, when you pay that money, you have it for a whole year, right?
Yeah. You have it for a whole year. I don't have a trial period, but I have a 30-day money back guarantee. So if you, on the off chance that you go in there and don't like it, or it's not for you, then I'm going to refund you the money. It's no problem. I
Right,
just
right,
had this week. I had one. Uh, we were chatting, and then he asked me before he bought, and then he bought it, and a day later he came back and said, "I somehow this is not for me." He wants to. He decides to want to go more into the analytics side of the science, or of data science. Then there's no problem.
awesome. So you can, for 30 days, you can go in there and see if it's a good fit.
Yeah, of course.
Cool. That is all we have time for, unfortunately. But thank you, everyone, for your awesome questions. And I did just want to call out Andreas's links to those courses. They're in our description and pinned to the top in the comments. And you'll also get a link to that with the replay of today's event. Andreas, thank you so much for your time. This stuff is so fascinating, and I appreciate your ability to like distill it into a usable framework to understand where the like data engineer sits within the equation and how it all works. So it's been a blast. For everyone watching, thank you for being here. If you're watching the replay as well, hop in the comments, join the conversation. There were a lot of awesome questions here today, so there's a lot of value in those comments. And if you had a good time today, please like and subscribe to the Spotlight YouTube channel. We're consistently trying to bring folks like Andreas out here to share their expertise on computer science, art, engineering, all these kind of things. It's a wonderful space. And go back and browse our YouTube for other events as well if you're looking for more free resources before diving in. Andreas, anything you would like to say before we sign off today?
No, thanks, Jonah. Thanks for
Yeah.
inviting me.
Yeah.
Really nice moderation. It was
Yeah.
very nice talking to you.
Yeah.
Very nice selection of the questions.
Yeah.
So yeah, it was awesome.
It's
Thanks.
such a blast. And last thing, just everyone, please hop in the comments. Thank Andreas for his time. It's been a wonderful event, and we'll hope to see you soon. Have a wonderful day.
See you.